All right, the video has not been working or coming up for some of you, so I'm just going to make a new one here. On the Chapter 1, take home. First questions. Let me zoom in a little bit on this. Okay. Question says, given the points, and I'm going to quickly sketch these points. -1, 4, and 3, -2. This is A and this is B. It says find the length. Well, the distance formula is, of course, the square root of x2 minus x1, which is the change in x squared, plus the y2 minus y1, or the change in y squared. Now that's because the change in x is just that length, and the change in y is this length, and if we want the distance between them, we do a squared plus b squared equals c squared, the Pythagorean theorem, and then take the square root, and so square root of a squared plus b squared. Now, I like to get the change in x and change in y by writing down, see, a is, excuse me, -1, 4. I'm just going to make a table here of x and y. And b, excuse me, is 3, -2. So the change in x, it goes from -1 to 3, that's +4. So the change in x is +4. And the change in y goes from 4 down to 0, down to -2, that's down 6. So that'd be -6 squared, the square of each of those, and then the square root. 4 squared is 16. -6 times -6 is +36. And add those together and you get the square root of 52. And some people got bonus for recognizing that that was the square root of 4 times the square root of 13, or 2 square roots of 13. But it would have been fine. You got full credit with the square root of 52. Now find the midpoint. And that you just do the average of the x's and the y's. I hope that probably went off there. There's the last part of that. Midpoint is the average of the x and y. So to find average, you add up the x's and divide by 2, and add up the y's, y1 plus y2 divided by 2. So we have the x's -1 and the other x is 3. So -1 plus 3 divided by 2. And we add up the y's, 4 plus a -2 divided by 2. -1 plus 3 is 2 divided by 2 is 1. 4 plus a -2 is 2 divided by 2 is 1. So the midpoint is 1, 1. And if we look at the graph, if we go to 1, 1, that is about halfway between A and B. C. Find the coordinates of C. On here, someplace C, if A is the midpoint of segment B through the midpoint to C. So it has to be back here. So if we went back, the change in x was 4. So if we go back 4, then we have to go up 6 to get to A based on these changes. So if we want to do that one more time, back 4 more. And this was at -1, so if we go back 4 more, that's going to be at minus 5. In other words, we're taking this table back. 3 to minus 1 back 4 more is negative 5. And take this table back 1 more. So if I'm going this way, it's minus 6. So this way it's plus 6. So I go plus 6 again. 4 plus 6 is 10. Okay? Now, let's go to D, I. So we're trying to find the equation in the slope-intercept form. That's y equals mx plus b. So we need the slope. But slope is the m, and it's change in y over change in x. And we found the change in y was negative 6, and the change in x is plus 4, and that reduces to negative 3 over 2. So we have the equation is going to be y equals negative 3 over 2 times x plus the y-intercept. Now, an equation, just so you understand, some people don't get this yet, so I'm going to explain. It's supposed to tell me, if I give the equation an x, it should tell me the y that goes with it. Or if I tell it a y, it should tell me how to find the x's that goes with it, that makes both sides equal. So we have 2 points up here, the minus 1, 4, and the 3 minus 2. Either one of those should be able to go in, the x part should be able to go in for the x, and the y part should go in for y, and I should get a true statement. So the number out here that I have to add, that I got to figure out, should be the same for both of them. So I'm on the side, I'm going to write, in place of the y, I'll put the 4 equals negative 3 halves the x that goes with the 4 is a minus 1 plus something. Now, I should be able to solve that and figure out what the something is that I have to put in here that makes it work for all points. So, minus 1 to minus 3 halves is plus 3 halves, which is 1.5. 1.5 plus 2.5 will make 4. So the something for this point has to be 2.5. Let's see if that also works for the other point. So if I put in 3 and negative 2, if I put 3 in there and add 2.5, let's see what I get. So 3 times negative 3 over 2, and this is 3 over 1, so I multiply the numerators, I get negative 9 over 2 plus 2.5. 9 divided by 2 is 4.5, so I got negative 4 and 1/2 plus 2 and 1/2. That comes out to be negative 2. I started with 3 and got the y to be negative 2. Started with a 3, ended up with y being negative 2. So that 2.5 is correct. That's a good way to check yourself. Okay, so that's that problem. Now, to get the equation with integer coefficients, I'm going to show it 2 ways. The way, one way is to take the equation we just got and convert it, and the other is, I'm going to show you, is the way I like to do it. So, let's start with this one. So I had y equals negative 3 halves x plus 2.5. That's 5 halves. I'm seeing this denominator of 2. So I'm just going to multiply everything by 2 so that I have integers. So 2 times y is 2y. 2 times this is going to cancel the 2 and make negative 3x. 2 times this is going to be plus 5. Now, to get it look like this one, I just need to get the negative 3x on the other side. So I'm going to add 3x to both sides, and I get 3x plus 2y equals 5. Now I'm going to get that equation again a different way. I'm going to start with something that you should know, that in an equation in this form, ax plus by equals c, it really comes from the change in y times x minus the change in x times y equals a constant number. So the change in y up here was negative 6. So I have negative 6x subtract. The change in x was plus 4. So I got a plus 4y. Should always be the same number. Now, just like I found b by plugging in stuff, I'm going to plug in. I'm supposed to be able to put in minus 1 and get and a 4. Minus 1 in for x and 4 in for y. If I just do this in my head, negative 6 times negative 1 is positive 6. Subtract 4. 4 times 4, that's negative 16. So 6 minus 16 is negative 10. So the c should be negative 10. So I have negative 6x plus minus 4y equals negative 10. And that would work. I could also divide this all by negative 2. Divide that by negative 2 and I get the 3x. Divide that by negative 2 and I get the 2y. Divide that by negative 2 and I get the 5. So these are the same equations, just multiples of each other, but they're the same equation. So that would also work for getting the equation. And I used the minus 1 and 4. I could have used the 3. Let's show that. Negative 6 times 3 would have been negative 18. Negative 2 times negative 4. Negative 4 times negative 2 would be plus 8. Negative 18 plus 8 is also the same constant, negative 10. Okay. E. Find all the coordinates on the y-axis that are 5 units from B. So going back up here to this, on the y-axis, well, B is 3 from there, and I got to be 5. So I can't go straight to it. I got to angle up here someplace, I don't know where for sure, so that it's 5 to hit some place on the axis. And since I'm on the y-axis, I'm not to the left or to the right, so the first coordinate is 0 for x. And then I'm up some amount and or down some amount down here that I don't know, so I'm just going to call that amount y. And b, of course, was the 3, negative 2. So I just write the distance formula. Now it says 5 units from B, so the distance is 5, is the square root. 5 is the square root of the change in x, so that goes from 0 to 3 on the x, so that's a change of 3 squared, plus now the change in y. Well, that goes from y to negative 2. So I do y subtract negative 2. That's how you find the change. Y minus a minus 2. So there's the distance has to be the square root of the change in x squared and the change in y squared. Now all I have to do is solve for the y. So I'll get rid of the square root by doing the opposite of square root, that's squaring. So I get 25 equals 3 squared is 9, the square root's gone, plus, and this is y, minus and minus is plus 2 squared. Now I'll continue solving for the y by getting the farthest way, the last thing out of there, so that's minus 9 from both sides. And I have 16 equals y plus 2 quantity squared. Now I'm going to get rid of the square by square rooting both sides, but I got to remember I'm square rooting both sides, so I have to remember it's plus or minus. The square root of 16 is 4, but it could be plus 4 or it could be a negative 4. And the square root of this squared cancel, and I got equals y plus 2. So if I subtract 2 from both sides, I get y equals 2. Subtract 2 from both sides, or y equals negative 6. But y equals 2 is a horizontal line. I need to write the coordinates of the points. So the points were on the y-axis, 0 and something. So I have to finish this by saying the points are 0 when y is 2, that's one place. That's 0, 2 up here, that's 5 away. And then the other place is 0, negative 6. That's the answers. Now, next one says, find the equation of the line parallel to AB. So, parallel to the line through AB, but going through 1, 0. Well, this line's close to it, but it's not quite there. It's going to have to adjust the y-intercept. So I'm going to throw out the 2.5, but keep the rest of it so it's got the same slope. I'm going to do it with this equation and with this equation. But I'll do it with this equation first. So I'm going to say it's going to be y equal negative 3/2 x, but it has to have a new y-intercept so that the 1, 0 works in the equation. So if I put 1 here and 0 here, I have to have a number that makes this true. Well, if I have 1 times minus 3/2, that's negative 3/2, plus what is 0? Because it's supposed to come out to be 0. Well, it'd have to be plus 3/2. And there's the equation of the line parallel. Had the same slope because this part didn't change. Now if I take the other equation, 3x plus 2y equals 5, I throw it out, these control the slope. You know, see the negative 3/2? The negative 3/2 came from that, the 3 and the 2. So that stays the same to be parallel. And if I'm going to go through 1, 0, 3 times 1 is 3, plus 2 times 0 is 0. So I get 3 is what it always equals. So that's actually easier than that one, I think. There's the parallel lines. Now let's do the perpendicular. Now if this goes down 6 and over 4 to be perpendicular, we have to go up 4 and over 6. So don't go down, this is not a negative slope, it's a positive slope. So the slope is opposite in sign, and this was down 6 over 4, down 6 over 4, or down 3 over 2. So the perpendicular is going to be up 2 over 3. So the slope would be 2 over 3. So if I write the equation then, it's going to be y equals 2 over 3x plus a new y-intercept to go through 4, 2. So if I put 4 here, I'm supposed to come up with 2. 4 times 2/3, that's 4 over 1, so 2 times 4 is 8. 1 times 3 is 3. 8/3 plus something has got to come out to be 2. Well, 3 goes in an 8, 2 with 2 left over, 2/3. So if I take 2 and 2/3, I'd have to add a negative 2/3 to end up with 2 to get rid of that 2/3. So negative 2/3. That would be the perpendicular. Now let's do it with this equation. Since the 3 and the 2 control the slope, leaving the x where it is, leaving the y where it is, to get the perpendicular, I switch the places of these two, just like we switched the places of the 3 and the 2. So I'm going to put the 2x and the 3y here, and we changed it, the negative 3 to a positive. We got to change one of the signs. I'll just change that 3 to a negative in there. They were both positive, now one of them's negative. One of them was negative, so now they're both positive. That's changing the sign. Equals some constant. If I put 4 in for the x and 2 in for the y, that's 8. 2 times 4 is 8. Minus 3 times 2 is minus 6. 8 minus 6 is 2. And that would have been the equation of the perpendicular. Okay? So that's part one.